this video, I'll just quickly demonstrate a shortcut method for calculating 3x3 determinants. So just recall the old method, slightly more complicated formal method. The idea here is that you just take each element in either a row or a column of the matrix, multiply each of those by the minor, basically the determinant of what would be left behind if we crossed out that row in the column, and then add them all up, alternating signs. All right, so let's do that procedure really quick, just to kind of appreciate that there is a faster way. So I'll just pick the first row because why not? And the first element in the first row is a 1. If I cross out that row in the column, I'm left behind with a 6, a 5, a -8, and a 2. Next, I'm going to alternate the signs. So it's going to be a minus. I'm going to pick the second element in the first row, which is the 4. Cross out that column in that row and multiply by the determinant of what's left behind. Okay, last, I'm going to take the third element, cross out the row in the column, and multiply by the determinant of what is left behind. Now let's try to quickly do this. So it's going to be 1 times, let's see, 6 times 2 is 12, minus -40, so that would be plus 40. Next it's going to be minus 4 times -2 times 2 is -4, minus 35. Last would be a 3 times -2 times -8 is positive 16, minus 42. Okay, so it's going to be 1 times 52, minus 4 times -39, plus 3 times -26. Okay, multiplying these, 1 times 52 is, of course, 52. And negative times a -6 is positive, and you get positive 156. And then the last would be a -78. Adding those together gives you 130. And while I did that pretty quickly, I also calculated these numbers in advance. You would probably take out a calculator at some point here. All right, let's do this again, but with a shortcut method. So this is the shortcut. It saves you maybe a minute or two. It's not a huge shortcut, but it is a little bit easier to remember and to do. All right, so starting with the same matrix, what you're going to do is you're going to take the first 2 columns and write them after the final bar. So I'm just going to take these 2 columns and write them again over here. So let's see. It's going to be a 1, a -2, a 7. 4, 6, -8. Next, you're going to multiply all the diagonals starting from the upper left to the lower right. So multiply this way, multiply this way, multiply this way. All right, and if we do that, let's see, 1 times 6 times 2 is going to give you 12. And I'm going to add to it the next product, 4 times 5 times 7 gives you 140. Here we have a negative and a negative, so that makes a positive. Let's see, 3 times 2 times 8 gives you 48. Okay. Next, you're going to go in the other direction. Start from the lower left and go to the upper right and do these 3 diagonals. You multiply the entire diagonals and then you add them up. And you're going to subtract this from the original. So I'm going to subtract what all the product of each of these the blue diagonal rows added up. All right, so 7 times 6 times 3 is 126. Then I'm going to add to it -8 times 3 times 1, which gives you, oops, sorry, that's not a 3, that's a 5, I think. Hold on. Yeah, that's a 5. So -8 times 5 times 1 gives you -40. And then last one is 2 times -2 times 4 gives you -16. Yes. Okay. So the sum of all the blues are, sorry, the reds, sum of all the reds are 200. And then the sum of all the blues is 70. Subtract those and you get 130, which is the same value as we calculated before. And as you can see, this is actually substantially less work, at least less writing, and a little bit less confusing. So either way, you're going to get the same method, the same determinant. It's just, this is a shortcut way of doing it by hand.